Hello students, welcome to Physics Pathshala. Today we'll be covering motion in a straight line part 2, that is our motion under gravity and relative velocity. Now let us start motion under gravity or vertical motion in straight line. That will be our motion under gravity. Under motion on gravity, will be experiencing one will be our upward motion and another will be downward motion. In both cases, all the kinetic equations will be applicable and it will hold good. This upward motion, when object will be moving from ground to certain height, and in downward motion, object will be falling from certain height to ground. In both cases, kinetic equations are V is equal to V0 plus AT, V square is equal to V0 square plus 2S, and S is equal to V0t plus half AT square, and the another fourth one, essence equal to V0 plus A by 2 times 2n minus 1 will hold good. Now let us discuss on upward motion. In upward motion, object can be on ground or on some certain height. If the object is on ground and it is thrown upward, it will go upward direction and attain certain height, and it will come back and reach ground. At maximum height, the final velocity will be 0. In second case, if any object is thrown from certain heights or some building, it has some height h1, again it will attain certain height and it will come back to ground. At this maximum height, velocity of the object will be 0. If the body is thrown at an initial velocity u or v0 and it has reached certain height h, using kinematic equation we say v is equal to v0 plus at. While going upward, our acceleration is will be g, the acceleration due to gravity, and velocity decreases, hence the sign becomes negative. Here v becomes 0, v0 the initial velocity remains same, a becomes minus g, and t becomes our t1 time of ascent. Here again 0 becomes v0 minus g t1. From this we get t1 is equal to v0 by g. Value of g is 9.8 meter per second square. Acceleration due to gravity. While coming down, during downward motion, for downward motion, initial velocity is 0 and it hits ground with certain velocity v. During the motion, it covers a distance of h and time taken is t2. This time of descent will be same as time of ascent, as in both cases magnitude of acceleration is called g and distance is same and velocity difference also same. We assume and you find out t2 is equal to t1 is equal to t. Value of t already you have got from equation. V is equal to, during upward direction, v was v0 minus gt and t was v0 by g. Here again t became v0 by t and total time of flight became t is equal to t1 plus t2 is equal to twice of t is equal to twice of v0 by g. Here t1 is equal to t2 is equal to t. Now let us discuss during downward motion, the body if hits ground with certain velocity, that is the final velocity of the object during downward motion. Again the equation of kinematic is applicable. V is equal to v0 plus at. Here initial velocity during downward motion is equal to our 0 during downward motion. Now we get v, the velocity at which object will hit the ground, will be our 0 plus g t again that becomes g times t, which is equal to g into v0 by g, that is v0. That is this v0 velocity at which object was thrown during upward motion. It implies velocity at which object will hit the ground will be same as velocity at which it was thrown from ground. As a special case, if an object is thrown from at a height h1. It may be height of building. It will attain certain maximum height, like it will go to h2 height, and it will come back and hit the ground. The total height will become h1 plus h2. Let time it will take t2, then it will reach, while coming again it will cover h2, and from here to ground it will be h1. And while coming, total height becomes h1 plus h2. Time it will take t2, and it will be let t3. Again here also equations of annuity will be applicable, and at maximum height while going upward, during upward motion, the final velocity is equal to 0. If body is thrown with certain initial velocity, here v is equal to 0. v0 is your initial velocity, time is equal to t2, and distance moved will be our h2. While coming down or during downward motion, initial velocity becomes 0. That the maximum height was at B and it hits ground at C. This is initial velocity, that is at B. During upward motion, final velocity was at B. Initial velocity that is at A. During downward motion, initial velocity is 0, and final velocity at which it will hit the ground, let V, with which object will hit the ground. At position D, velocity will be v0, t2 will be time period, or time will be taken for the object to move from B to D, and distance will be h2. Distance it will cover from B to D. Now from D to C it will move and hit the ground at C. Let at C velocity is V, is final velocity, time will be t3, initial velocity will be again v0. Applying kinematic equations, we can get time, final velocity, height using three equations of kinematics. Let us consider motion for a freely falling body. What is freely falling body? Freely falling body is the body which is thrown from certain height at initial velocity 0. Now it will accelerate towards ground. For acceleration will be our acceleration due to gravity g. Here the motion is completely under action of gravity and velocity increases. Hence the acceleration is positive. Now let us study relative velocity. Relative velocity is the velocity of an object with respect to velocity of certain reference object. When two objects are moving, it will be the relative velocity between them. We can categorize relative velocity under movement of vehicles and crossing the river or swimming along the river. This is our vehicle related. Let it be bus or train or any other vehicle. Another is crossing the river from one side to other side of the river. Another is moving along the river using boat or swimming. Using boat or swimming. Here crossing the river also same, using boat or swimming. Now let us discuss on relative velocity for objects or movement of vehicles. Or when the vehicles are in motion, the comparison between velocities of two vehicles are termed as relative velocity between them. Suppose on vehicle A and another vehicle is B. Velocity of V with respect to ground is VA, whereas velocity of V with respect to ground is VB. Now, velocity of A with respect to B is our relative velocity between vehicle A and vehicle B. We will have two situations when both vehicles are moving in same direction. or it may move in opposite direction. In both cases, both are moving in parallel direction condition. If both are in same direction, relative velocity will be VAB will be velocity of A minus velocity of B. Whereas relative velocity of V with respect to A will be velocity of B minus velocity of A, and in both cases VAB will be minus of VBA. This is a case of parallel motion, and it can be both the vehicles in same direction or both the vehicles in opposite direction. If they are moving in opposite direction, VAB will be VA plus VB, because as it is a difference between two VA minus of VB, but direction of VB will be opposite to VA. In that case, it becomes VA plus VB, and VBA also VA plus VB. In this case, VAB equal to VBA. This is the case of relative velocity when two objects are in parallel motion and in opposite direction. Now let us consider other motion, that is, if we say relative velocity is found out for parallel motion and perpendicular motion. Parallel motion is vehicles in same direction or in opposite direction, and in perpendicular motion will be studying crossing the river using boat or swimming. Let us consider relative velocity during crossing the river. We'll have one while man or any boat is moving along the flow of river water, or it is perpendicular to flow of river water. While the boat is moving along the flow of water, it is a case of parallel motion. Let velocity of river is VR and velocity of man is Vm, and relative velocity of man with respect to river is Vm minus Vr. If moving along the flow of river, Vm minus of minus Vr, which is called our Vm plus Vr. If man is moving man, if the object in a boat or man is moving opposite to flow of river. While crossing the river, suppose flow of river is VR and Vm is velocity of man in still water. That means when there is no velocity of river or VR is equal to 0, the velocity of man is Vm. In that case, while crossing the river of width W, velocity of man is Vm and time it takes is t. Then W becomes Vm into t or Tm. T is equal to W by Vm. That is the time it will take to cross the river. Or velocity of man should be width by time. This is the case when VR is equal to 0. Now let us consider when, this is case 2, when VR not equal to 0, means the river has certain velocity. Let VR is velocity of river and Vm is velocity of man. The relative velocity will be, let V will be W by T. V is the relative velocity and Vm is velocity of man or boat in still water, and Vr is velocity of river. In that case, to cross the river with shortest distance, man has to swim at an angle let it is our let it is some angle theta. Man starts from O, it has to reach B, it will move in a direction A, is Vm, this is velocity of river, it is a vector addition and it will be resultant will be our V. Suppose this has to be V. V will be Vm and Vr. This is our requirement where V will be width by time. This will be the case to cross with shortest distance. To cross with shortest distance. Now we get OA plus AB is equal to our OB. Sine of angle alpha, or in this case sine of angle theta is equal to VR by Vm. If swimmer makes an angle alpha with upstream, that means with direction of river flow, then in that case cos of alpha becomes VR by Vm. Considering the right angle triangle, so alpha, this is A, this is B, this is O, this is Bm, and this is Vr, this is V. Bm square is equal to Vr square plus V square. From right angled triangle, we know B square is equal to Vr square plus B square, which gives V square is equal to Vm square minus Vr square, or V is equal to Vm square minus Vr square. To find out the shortest distance, it will cover, the time will be taken as let t1 will be width by velocity, that is W by Vm square minus Vr square. This is the time it will take to cross with shortest distance. That means swimmer or the boat will take time to cross with shortest distance. Shortest distance is our W. In that case, it has to make an angle alpha with upstream, or theta is the angle it will make with width, whereas our or sin theta will be VR by VM, or theta will be sin inverse VR by VM. That means when this condition is fulfilled, the swimmer or boat can cross the river with shortest distance W. Let us consider to cross the river with shortest time. To cross this river with shortest time, let T2 is the time it will take. Is let W is the width of the river, VR is the velocity of river, VM is velocity of man. In this case, man should swim perpendicular to river, and T2 will be our width by velocity of man. In this case, man will touch the opposite bank of the river at B. That is, AB will be the distance which will be VR times T2. So it will be VR into width by VM. So the VR by VM into W. From this, as a special case, if here will be 0 or there is no flow of river, man will touch at opposite bank at A, because once VR will be 0, AB will be 0. In next class, we will start vector related problems, vector and motion in plane. Those have not subscribed, subscribe to this channel to get the next videos in time and to remain in contact. Subscribe and press the bell to get the notifications immediately videos will be uploaded.